Hello, ladies and gentlemen. Welcome to another exciting edition of How Do I Do This Anyways? Today's topic of conversation, analyzing your histograms and your dot plot data for your, um, not trammel toy, but you guys are doing the tolerance block holes. You guys your assignment are working on the size of each individual hole that you've selected. I'm going to show you how to do that on the tolerance block thing. So, first thing, we're going to be taking your data, which looks something like this, probably, where it's kind of way skewed out and you've got it going way, way far out. And we're going to be changing that data into looking something more like this, where you have it more what's referred to as normally distributed. Now, when we were working on our slide blocks and we wanted to clean up our data, you remember how we just cut off the top and the bottom, and that was kind of an arbitrary way to do it. And I told you that there was a better way to do it. Now it's time to learn that better way to do this. Okay. So I'm going to go ahead and take my original histograms that I made. This would be what you guys worked on the prior day. I believe that was Friday for you guys, where you created this frequency versus value chart and you were supposed to do a histogram chart. And I told you to create 7 bins for that histogram. So with that, you should have found the range of your data and then found 7 equal sized bins for that data to be kind of sorted into. And that's what we are seeing with this little chart here. Our range size, if you go ahead and click on your histogram, you can click that and you can set the bin size to be whatever you feel like. Okay. And so I went ahead and set that bin size to be this. Now, this data, if we go ahead and we look at this thing and we sort this according to that range, okay? Whoa, undo that. That's not what I want to do. I want to sort it by my data's range. There we go, wrong column. Uh, Tools, data, sort range from A to Z. If we click on this, we see that some of our values are in the 0.76 and some of our values are 1.94. Okay. Now, before we just kind of casually chopped those off and didn't think much about it. But what we want to do is we want to do a statistically valid way of eliminating those outliers. Because the thing about your data and the thing about outliers is that all of your data is going to end up having outliers. Any measurement you take, if you look at a dot plot, you should have most of your measurements right along the mean, and then they should taper off as you get farther away from the mean, smaller, and farther away from the mean, larger. Okay, so your dot plot distribution, you should see this nice bell curve if everything is done correctly. Now, with the way that using your standard deviations and the empirical rule, an empirical rule is just saying that your data falls within a certain number of standard deviations from your mean. The good rule of thumb is 3 standard deviations. So you want your data to be within 3 standard deviations smaller and 3 standard deviations larger. That's where most of your data should lie. Um, if you just casually glance at the data that I have here, that may or may not be true. In fact, all of my data looks like it's right there. So what we're going to do is we're going to go ahead and look at a good way to clean up your data. But before you do that, what you want to do is you want to make sure you're not changing the work that you did in the past. You want to see a before and after of this. So I'm going to click right here and I'm going to click duplicate. And I'm going to duplicate this sheet that I'm working on. Okay, it took a moment to copy it, but that's fine. So I've got my height values here. Let's give it some more time to think. Yeah, so that's my duplicate of this, okay? So I'm going to go ahead and rename this analysis of square slide block histograms, because what we're going to do is we're going to analyze this data and we're going to clean it up a little bit. So now, first thing we want to do is instead of having our bin size, which is the size of increments that we kind of categorize this data into, instead of that being just some arbitrary number because we wanted 7 bins, I'm going to go ahead and tie that immediately to my number of standard deviations or my standard deviation size. So I'm going to hit 0.211. Okay. Now, I'm also going to go ahead and figure out this. I'm going to figure out where my lines are to start cutting off my data. If you look at this, we want to be 3 standard deviations below and 3 standard deviations above our mean. So I need to know what those numbers actually are. So I want to say mean plus 3 SD, and I also want to know mean minus 3 SD. Okay? So now what I'm going to do is I'm going to just make an equation, hit the equal sign, open a parentheses, and I'm going to take my mean, and now I'm going to add 3 times whatever my standard deviation number is. Now I'm going to close my parentheses, hit enter. So 1.54 is my maximum cutoff. Now my minimum value, I'm going to say mean again, so equals, open a parentheses, click my mean value, minus 3 times your number of your standard deviation. Okay, now I'm going to hit enter. Okay, so what that means is that if my value is below that 0.27, I should get rid of it. And if it's above that 1.54, I should get rid of it. So just looking at this, I don't have anything that's below 0.27. Okay, but this 1.54, if I click down here, scroll all the way down, 1.54, I can get rid of all of these pieces of data. Okay, now instead of just deleting them, copy them. You remember how I told you to put a row between here? I want you to copy and paste them over so that way you can see the data that you have gotten rid of. So copy, paste. Now we are going to delete those. Okay. Now let's look up at what happened to our standard deviation. Our standard deviation is now 0.03. And you see what happened to our cutoff range? And you see what happened to our histogram? All of our data is in the bin. So we need to change our bin size. We're just going to keep going back and forth on this, changing one thing, then changing another, until we have tweaked this enough that we actually see normally distributed data. Okay? So looking back here, now I've got my mean value, which is 0.86. That's up here. And then I have my other values up here, which seem to be way high. So if I look at mean minus 3 standard deviations, I'm at 0.7713. Do I have any data below that? Yes. So I can take, or I'm sorry, over here, I can take that one, copy it, paste it over here, and delete that value. And now it's making my data look even better. Okay. Now I'm going to go ahead and delete that other one, which was 0.95. So looking at this, what was it, 95 and change? 0.9548. So anything above 0.9548, I'm going to do first, copy it, paste it to move it over so we can see what we're doing, and then get rid of that. Okay. Now let's look at what just happened to our standard deviation. Our standard deviation is now 0.0126. This is looking even better. Now, I'm going to change my histogram to be that 0.0126. Enter. Okay. Still getting some variations here. However, if I look at my mean value, 0.857, 0.857 is somewhere right in there. Okay. Now, I could keep going and whittling this down, but I've now done this process 3 times. And what I'm seeing right now is I have mostly normally distributed data. Yes, I've got it skewed a little bit this way, but if I look at my mean value, which is right here, hover over it, I got 92 pieces within that, and then I've got 6 pieces there, and that is 1 standard deviation would be to here, 2 standard deviations would be to here, and 3 standard deviations would be to here. just following that empirical rule, 1, 2, 3. I would say that most of my data is now within those 3 standard deviations. Okay. So that means that I now know basically how big my numbers are or how big that hole is to within a certain degree of certainty. Okay. Now, when you're going through this, you just have to figure out what looks good and what doesn't. Also, you have to be able to justify it. So, like, I could keep whittling away. I could look at this and say, okay, now I want to take out this 0.89. That'll clean up this point. Let's go ahead and do that. 0.89. Anything above 0.89, I'll get rid of. I got this 0.9. Control C, Control V, delete that. Now my standard deviation is 0.008. Now keep in mind, we only measured to the 10,000ths place. So 100 tenths, hundredths, thousandths, 10,000ths. So just looking at that, customize my chart again, 0.0084. Enter. Now, my mean value is still 0.85, 0.856, right there. That looks even better. But you can keep doing this and whittling it away. The thing is that you can't get rid of all of your outliers simply because there is always some variation in your product. So what I want you to do right now is I want you to first off read about the empirical rule. Then I want you to apply it and see if your data is normally distributed, meaning that 99.97% of your data falls within 3 standard deviations of your mean value. It might help to print out your graph so that way you can actually physically mark on this, but you should be able to take some screenshots of this also and write down a couple of notes. It might be easiest to just do this in a Google Doc. So hopefully this helped you out. And if you have any questions, let me know.